switching.
Hi, good afternoon. I'm Arne. I'm from Mellanox Technologies, and I would like to talk a bit about Ethernet storage fabrics. And doing that, I have brought something to pass through. Please don't take it with you. Very important parts are missing over here because it's more or less a mock-up, so it's showing to you what a nice Ethernet storage fabric switch might look like. And if you just pass it around, the colleagues in the back, they will collect it later on. Okay. First of all, a question I would like to ask, who of you knows Mellanox or knows the name of Mellanox already? Oh, that's quite a few guys. That's great. The guys in the back don't count because they are the colleagues. All right, just to give you a brief introduction, because we learned throughout the time, especially over here in Central Europe, that we are not well known in the Ethernet market because we are just about to start with everything. We were founded back in 1999, so we are a public organization spread worldwide with around 2,900 employees. We're doing high-performance computing, we're doing InfiniBand and Ethernet, and this is our background. So what we do is we develop and build hardware from the ASICs and the switches, the ones that are passing around, via the NICs and the cables, and of course, including the operating systems. So we provide a holistic end-to-end solution for high-performance computing and for Ethernet. And what we found out throughout the last few years, and this is the trend that's currently going on, is that data centers and data center switching currently is changing rapidly. Almost on a month-by-month basis, you see new terms coming up, you see new technologies coming up, you partially see new vendors coming up. Why is it that case? One thing for sure is that storage really develops from the traditional SAN to a more sophisticated, a more scale-out server SAN. For a very basic reason, the development of FiberChannel, for example, stopped at a certain point. They do not develop into higher throughput, they do not develop into higher IOPS, and of course they do not scale that well because it's a fairly complex technology. And I did FiberChannel for quite a few years. It's a nice technology, but it's not commonly used, and it's a SAN, an island solution. Why is this the case? The new technologies in storage right now demand more and more throughput and more bandwidth. When you just look at the upper right graph over there, we now have flash storage. So we are going from the typical rotating hard drive to flash storage to NVMe over fabrics, and we demand more and more throughput. You will see some information about this later on. We also have now the common trend, not only in the high-end technologies and high-end organizations, that we go from pure blade servers and from the... I hear some music, which is not too bad. So that's nice. So we go from the typical iron of physical servers to virtualized environments, to virtualized servers, to high density of functionality within your data centers, which of course dramatically also changes everything around it. So we're going more and more into the cloud. And cloud is not the public buzzword we have these days anymore. We have cloud providers and we have service providers, but also in the small enterprise, small business, we find cloud solutions these days, because cloud in the widest sense is more or less then we virtualize almost everything. Part of the virtualization, however, is also related to the storage. And what we know from the storage so far is that we have the traditional storage environments, and in the traditional storage environments, you see it up there, we have the traditional SAN, we have the traditional mission-critical applications, storage applications, so we have disks, we have tape libraries, all this is the traditional approach. However, in times of big data, in times of massive backups, in times of data pushed up to the cloud, not only once, but several times and spread out all over the world, we have a high ratio of data that has to be stored somewhere. And it has to be stored as close to the user as possible. And the user in the data center typically is the server, the front-end server. So the closer we get to the front-end server, the better it is. And we have to provide reliability in terms of providing the data to the front-end servers. In other terms, we need to have a lot of backup. So traditional storage, as we know it, now all of a sudden has blown up, and the storage vendors say, hooray. We build just larger boxes, and we sell just larger boxes. But the drawback of this solution really is that you get away from the real user and from the real end system that is used. Just to give you some examples of what is really needed, the new storage media would need faster and faster networks. And just starting with the typical traditional hard drive, you see over there that a traditional hard drive has no problems running at 10 gigabit, because with 24 hard drives, you are just likely to saturate a 10 gig link. So if you have a storage network, 10 gigabit usually is okay for your storage servers. It does not place any impact, and there is no challenge and no issues. With the introduction of SATA SSDs these days, we start all of a sudden seeing that with 2 SSDs, we can saturate a 10G link. How many of you use storage with 10G? If at all. No one? Some guys do. Do some of you use storage with already 40G? At least one. No one else? Well, no one else is doing storage, I guess. When you look into newer technologies, and some of you might already use SAS SSDs, one SAS SSD saturates a 10 gigabit link. This is not a storage network anymore. This is more something like a local storage somewhere in a server, but no other application may run over there. So if you look for the latest development of storage, when we look into NVMEs, then all of a sudden you see that 10G is by far not enough anymore. Is any one of you already evaluating NVMe storage solutions? You are? What is your experience? You need fast network, don't you? Mm-hmm. Yeah. It is nice. It's a nice solution. It's a very efficient solution, but you need faster networks. And this means that you have to bring your storage closer to the original or to the user, in other terms, closer to the front end of your network. Closer to the front end means less delay and better reachability and better throughput. So the line we draw these days is just a line, the storage just goes up where the network is. So you don't have a dedicated network anymore. You need a dedicated Ethernet storage switch. The small friend you see over there, which is called the SN2010, is a typical storage switch. You have 2 switches in one RU. You have a very, very high density port count for this RU. You can build a redundant solution for your storage. You have a native SDK. You can run applications within a container over there. You have the support for RDMA over converged Ethernet. You have no packet loss and a very, very low latency. And you have tools for optimization of the use, like, for example, a management tool, which we call Neo, which also integrates, for example, into VMware, which also integrates into OpenStack, Open Daylight controllers. And you have, and this is a very, very important point, you have the choice of the operating system that is supported by your networking guys. So it's an open switch. This is something we can discuss for ages if you wish to, but what is very, very important is that you need an ASIC that supports an Ethernet storage fabric. And the ASIC has to support microbursts, which means we have to buffer short times of peak traffic. not necessarily according to the bandwidth, but necessarily according to the amount of packets per second. You have to work without any packet loss. We've tested this. You will get the slides later on, and you will see that there is a nice report that displays it to you. This is the range. Just I don't want to do too much of advertisement over here, but the small friend, the SN2010, is an 18-port 25G switch with 4 100-port uplinks in just half rack unit. So you can push 2 next to each other, and you can build a complete small HCI or storage environment with everything that's necessary to run it. And the nice thing is that it is, even because of the design of the ASIC and of the design of the box itself, it is even more efficient than having 2 switches in 2 RUs. So you save space within your rack, which can be used for other functionality and other features, for more storage, for example, and you have more throughput and more efficiency in the transmission of the data. You now say, well, it's a small box, it only is for small environments, but it may scale up to dedicated bigger environments, and using bigger environments, you just say you add an additional layer. Just by the way, what is very important in these solutions is it's all standards-based, so there is no proprietary vendor lock-in. And saying that, it simply means that you can simply choose later on also other hardware, as long as it supports the standards. And we are living in a standards-based world in Ethernet, so you can feel free to use whatever you like. And this is the idea behind it. You can choose the best of breed, the fastest, or the one that meets your requirements in terms of feature, or the operating that meets your features. What we do in most of our projects, and I'm a system engineer, so I work within a lot of projects, is simply we start with sort of designing a blueprint for an environment. And this is what I simply suggest and recommend to everyone, no matter if you buy the PLNOG switches or not. It is fairly straightforward. When you think about redesigning your storage environment to an Ethernet storage fabric, the best approach really is start thinking about a blueprint. Start thinking about how should my storage look like here, for example, where you just start with a very small environment. If it gets bigger, you just pile up until your rack is full. And when your rack is full, you just add racks step by step. And this is quite easy because it really scales up to several thousands of ports. Just a small excursion, what you see over here, because this is something that's essential for a storage network, is RDMA over converged Ethernet. To cut a very long story short, RDMA over converged Ethernet simply means I bypass the kernel. Bypassing the kernel for storage operations means I save CPU cycles. Saving CPU cycles means I free up the CPU for other tasks, for other features that might be needed. Well, ROCE, however, how we call it, ROCE is an operation, a storage operation that simply requires a resilient lossless network. What you see over there is that most of the switches simply do not support it. If you have an Ethernet storage fabric switch that can do it, you can simply run a resilient and smoothly running application. There is one technical slide, and we can discuss later on because time does not permit to go into the details, but this would be a normal quality of service configuration for an RDMA or ROCE-enabled Ethernet storage fabric. The presentation before also talked about quality of service. My Polish is not very good. I must admit my Polish is very weak. But I saw that it was talking about DSCP and quality of service, and here we point out to simply very similar things. The problem really is when you go into quality of service, it might get bloody complex. However, if you have the correct switch that is storage enabled and that supports these protocols, you can do all this within just one single line. And then you get the best out of your storage network. This can be run on the switches, along with an operating system and a management, and it really supports a wide range of diverse storage solutions, storage applications, and storage appliances. And ending up with this, we simply have seen, and I hope that you get this message at least around, that with a storage optimized switch, Ethernet storage is not rocket science anymore, and it is simply a resilient, fully redundant storage fabric within your network that scales up to the needs you really have. If you have any questions, just pop through. We are just around the corner with the Mellanox booth, and we are happy to answer your questions there. Thank you very much.